Welcome back to the 31st part of debugging at scale, where logging doesn't stop in the backend. We discussed logging in the fourth module, but front-end logging is different in many regards. The first big difference is the quality of debugging via printing. As you may recall, I'm a big advocate of using trace points instead of logging. Trace points are still superior to print statements in most regards, but in front-end programming, the difference isn't as pronounced. In a front-end flow, we constantly reload, refresh, switch browsers, and as a result, the development is very fluid. A trace point can become a hassle as we test extensively. Features such as ingestion, logging to a file, etc., aren't as useful in the front end, and thus we don't have the same level of need for a logger. It's still a best practice to use a logger rather than invoking console.log directly, but it isn't as much of a problem as print could cause on the backend. One of the big advantages console has over simple print statements is its support for log levels. There are 5 supported levels: log, debug, info, warn, and error. Log and debug are indistinguishable from one another, and info is sometimes rendered in the same way. Here we can see the output of each level. The browser lets us filter the output so we can focus on a specific logging level, similarly to typical server-side logs. We can create completely custom versions of logging with CSS thanks to the way JavaScript works. We can add an additional logger method into console and use CSS to customize the output. The code here prints out Dazzle with a pink background. Notice we're using %C, which indicates substitution with CSS. After the comma, we see the CSS that's applied. Notice we can use more than one substitution blocks to mix CSS styles. This can let an API print out text with multiple distinct styles. The console trace method can print the stack trace to the current location. This isn't as useful due to the asynchronous nature of JavaScript code, but in some circumstances that might prove useful. Besides logging, we can use assertions in the code to implement design by contract. Assertions let us determine an assumption we make while coding. Assert is used to verify a statement that must be true. If it isn't, our application will fail with a clear error. In the browser, this isn't as dramatic and is closer to the effect of console.error, as you can see here. One of the most powerful features of asserts is the ability to strip them out in production builds. We can remove the performance overhead of testing everything while promoting a fail-fast mindset. Some minifiers support the ability to remove asserts in production. We can apply deep formatting to printed information. One common example is printing a table of data. See the code on the top here, which can print a table with the array of items. We can create more sophisticated examples by printing an object as a table. As you can see at the bottom area, the elements of the object become the columns and rows of the table. This is a very convenient way to view data in the console. Printing the content of an object to the console is possible in various ways. We can use the copy object method to copy the content of an object into the clipboard so we can paste it anywhere. The console.dir API provides a far more powerful option of inspecting an object as we do in the debugger. This is an amazing way to explore an API and the state of the environment as we see in here. Similarly, we can use dir XML to view an object as XML or use inspect method to open the inspect panel with the given element or object. Counters are an important debugging tool. We often want to know the number of times a method was invoked or a line of code was reached. This is such a common use case, it's coded into the console API. With console.count, we can increment an arbitrary number every time that line is reached. The current count is printed to the console. We can also use console.countReset to reset the counter back to 0. This lets us verify that an API isn't reached too often and validate assumptions. Grouping lets us collect related printouts together in a collapsible group to keep the output organized. We can place all the logs related to a specific method in a group to reduce verbosity. To start a group, use console.group group name. This opens a collapsible region with the given name. Every following printout will be a part of that group until you invoke console.group end. As you can see here, monitor is a Chrome-specific feature that lets us monitor calls to a specific function. This is like adding a trace point on a method breakpoint. We can invoke the function monitor on any function after that point. Every invocation of the function will print its name to the log and the arguments it received. Invoking unmonitor will remove the monitor and return to the previous state. Similarly, Chrome supports the ability to monitor events using the monitor events and unmonitor events API. All events are logged to the console once we start monitoring events until we choose to stop with the monitor events, unmonitor events call. The events argument is optional. It lets us reduce the volume of events we receive. I can monitor all window events using the monitor events window, or just specific mouse out events using monitor events window mouse out, as you can see here. Chrome can list all the objects created with a specific constructor or a specific object type by using query objects function. When we invoke that function with any object type, such as promise, as we see here, we can see the objects in the VM listed below. This can work with a constructor or get only the instances created with the specific constructor. I didn't know some of these techniques before I wrote this book, created this course. Maybe it's because I'm not a front-end developer. They are powerful tools we should all be using. In the next video, we'll discuss debugging networking issues in the front end. If you have any questions, please use the Slack channel to ask them. Thank you.